Hello, everybody. So today we should be talking about problem solving using the discriminant. So remember that in the quadratic formula, the expression b squared minus 4ac is called the discriminant. Okay, and that's this part that's highlighted right here. Okay, and we can use the discriminant to find information out about the equation. Okay, so mainly, how many zeros does it have? How many solutions does this thing have? And what kind of solutions they are? So if b squared minus 4ac is positive, then the equation has two real solutions. If b squared minus 4ac is 0, then the equation has one real solution. And if b squared minus 4ac is negative, then the equation has no real solutions. Now, be careful. It does have solutions. They're just not real, okay? So we'll talk about that a little later. I'm just going to talk about real solutions right here. So use the discriminant to determine the number and type of solutions to this equation. Okay, so what we're going to do is we're going to look at the b squared minus 4ac part. That's all we're going to look at right now. So b, I always like to label these up here first. In this case, A is 1/2, B is 6, and C is 14, okay? So then B squared would be 6 squared minus 4 times A is 1/2 and C is 14. Okay, so this is 36 minus, half of 4 is 2, and 2 times 14 is 28. And so 36 minus 28 is 8. Okay, it's positive, so that tells me that there is two real solutions to this thing. Two real solutions. Okay, now if we were to graph this thing, it would look like this. And sure enough, you can see that this thing crosses the x-axis here and here. So we're a little bit less than -3 and a little bit more than -9. You probably can't see that on this graph. We can figure out what those were if we use the quadratic formula. Okay, but we're not going to do that right now. We just want to figure out the type and number of solutions. Okay, so we're going to do the same thing here. Use the discriminant to determine the number and type of solutions to the equation. So I tell you what, why don't you pause the video, work this out, and then tell me how many solutions it has, and then check your answer against what I get. Okay, so here we have A is 1, B is -6, and C is 9. So we're going to look at b squared minus 4ac. So that's going to be -6 squared. Now make sure that that's in parentheses, especially if you put it in your calculator, because if you leave it like this, you're going to get -36, and that's not what you want there. You want +36, okay? -4 times A times C. Okay, so just remember, this part, this b squared part, this is always, always, always going to be a positive number. It can't be negative. It's always going to be positive. Okay, so this is 36 minus 4 times 9 times 1 is 36, and I subtract that and I get 0. Okay, that tells me that there is one real solution. All right, so if I graph that, what does it look like? It looks just like that. Okay, it comes down, it touches the x-axis, right there, and then it goes back up. That's why it has one solution. Okay, go ahead and do this one here. Use a discriminant to determine the number and type of solutions for this equation. I'll let you pause the video, calculate this really quick, and then jump back on and see how you did. Okay, so A is 2, B is 4, C is also 4. So when we look at b squared minus 4ac, it's going to be 4 squared minus 4 times a times c, like this. Okay, this is going to be 16 minus 8 times 4 is 32. This is negative 16. So that tells me this has no real solutions. Because remember, the discriminant is the part that you square root. And if I square root this all the way down, I can't square root negative 16. Okay, so what does that mean if I graph it? It means it's going to look like this. It has no real solutions because it never crosses the x-axis. Okay, so hopefully that's what you got. All right, here we go. We got a fire situation. Rick is a firefighter. He's leaning out a window on the 8th floor. He's trying to throw a grappling hook up to the 10th floor window, and this window is 26 feet above him. Okay. He can throw the grappling hook with a maximum speed of 45 feet or 40 feet per second. Can he throw the grappling hook hard enough to the window to hook above him? Okay. So we're going to go back and we're going to use the thrown formula, which was height equals negative 16t squared plus v times t plus s. Okay. So in this case, we're going to count the ground. We're going to count 0 as right here where he's at. Okay. Well, actually, it's going to be right here where he's throwing it. Whoops. Let's try that again. Right here where he's throwing it from is going to be 0 right here. So S, the start height, is going to be 0. Okay. Now, his velocity is 40 feet per second. That's our constant. And we need this to reach 26 feet. Okay, so what are we going to do here? Let's take all of this stuff and move it over here. That way we're dealing mostly with positive numbers. So I would add 16t squared over here. I get 16t squared. I would subtract 40t, and I would have plus 26, and that's all going to equal 0. Okay, now we can look at the discriminant, because the discriminant will tell us, is he going to be able to throw this thing clear up here 26 feet? Okay, is he going to make it? So, let's see here. So A is 16, B is negative 40, and C is 26. So we want B squared minus 4AC. So that's going to be negative 40 squared minus 4 times A, which is 16, times C, which is 26. Okay, so we're going to get out our handy-dandy TI-84 plus C Silver Edition graphing calculator. And we already know that negative 40 squared is going to be 1,600. That's easy. Now, 4 times 16 times 26. That's a little tougher. That's 1,664. So when I subtract these, I'm going to get negative 64. That means there's only imaginary solutions to this thing, which implies there are no real solutions, so he cannot, which implies he cannot throw the hook up to the 10th floor, up to the 10th floor. Just not strong enough to do it. Okay? So, let's move right along here. Okay, from 1960 to 1990, the total government payroll in the United States can be modeled by P equals 35t squared plus 115t plus 3,410, where P is in millions of dollars, and t equals 0 corresponds to 1960. Judging from the payroll pattern between 1960 and 1990, is it possible that the government payroll will reach $70 billion a year? Okay, so here's the thing. Here's our equation. 35t squared plus 115t plus 3,410. Okay, now this is important to be really careful with this. This is in millions. Notice this down here is in billions. So this has got to equal something in millions, but it's got to be 70 billion. So that's going to be 70 billion would be 70,000 millions. Okay. So now we got our equation set up. We're going to move this over here. So we're going to subtract 70,000 from both sides. So 3,410 minus 70,000 is going to become 35t squared plus 115t minus 66,590 equals 0. Okay, does this have a solution? So we can tell by just looking at the discriminant, b squared minus 4ac. All right, so we're going to do that first because we don't know if this thing even has a solution. So if we check this thing and it has a solution, then we can figure it out. Okay, so here a is 35, b is 115. So this is 115 squared minus 4 times a is 35, c is negative 66,590. Okay, I can tell this is going to have a solution because what's going to happen is that negative is going to cancel that negative. Let's see, 115 squared is going to be 13,225. Of course, you all knew that. 4 times 35 times 66,590 comes out to be 9,322,600. Okay, so we go ahead and add 13,225. This is 9,335,825. Okay, since it's a positive number, this does have a solution. So it is going to reach that much. Okay, so now we can go ahead and finish the equation because remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we just did this part right here. This part right here is that. So we're going to take this, and we're going to substitute it in here. Let's get another color. Okay, so x is going to be, so negative b, that's going to be negative 115, plus or minus the square root of 9,335,825, all over 2 times a, 2 times 35. All right, so we get out our calculator here, and we go ahead and we square root that. So x is going to equal negative 115 plus or minus 3,055.5, we'll round it, over 70. Okay, now remember it's plus or minus. There's going to be 2 answers, but we don't want a negative answer because this is time. So we're not going to go back in time. So we're only going to consider negative 115 plus 3,055. So this becomes 2,940. We're going to round it to 0.5 over 70. So divided by 70, that tells me 42. All right, what does that mean? Well, that's 42 years. So remember, year 0 is 1960. So we're going to take 1960, we're going to add 42 to this, and we're going to get that the budget is going to reach that in the year 2002. There we have it. If it follows that model. Okay. All right, so you got a few little problems here on the next couple pages. We'll do those in class. I look forward to seeing you guys. Have a great evening.